Now reaction intermediates of three types: carbon free radical, carbocation and carbanion. Now first we will discuss about carbon free radical. What is carbon free radical? These are the electrical neutral groups having a free electron on carbon atom. That means a unpaired electron on carbon atom. Now how it is formed? Normally these are formed by homolytic fission of covalent bonds, by which there is a equal distribution of electron takes place. Now carbon atom in a carbon free radical, this carbon free radical is sp2 hybridized, and due to sp2 hybridization the structure is a planar structure. And one important point for this is relative what is the stability of the free radicals. Now if you will see the example, tertiary butyl free radical is more stable than isopropyl, which is a secondary free radical, then which is also greater than ethyl free radical, which is a primary, then methyl free radical. Okay, this is the order of relative stability of free radicals. Greater is the number of alkyl groups, more is the stability of the free radicals. Okay. Now next is carbanion ends. Carbanions means what? When carbon is attached to a lesser electronegative atom Y, then heterolytic cleavage results in carbon atom acquiring the negative charge known as carbanion. Okay. Now see here, suppose if I will write Y here, another atom Y, and here also suppose in this example another atom Y. Okay, if the carbon is more electronegative than the Y, then the pair of electron which is present between carbon and Y, the carbon attracts the pair of electron towards itself. That means it becomes C negative and this becomes C positive. Okay, so the carbon having negative charge on it is known as your carbanion ion. Similarly, this is your methyl carbanion ion because CH3 minus. Here also same thing occurs. Now this becomes delta positive. Now this becomes ethyl CH3 CH2 minus. So it is ethyl carbanion ion. Okay. Now carbanion behaves as a nucleophile because it is having a pair of electrons with it, so it behaves as a nucleophile and it is readily attacked by electrophile because electrophile is electron deficient and it is electron rich species. Okay. Again, in carbanion, the negatively charged carbon is sp3 hybridized. Here it is sp3 hybridized, and due to the sp3 hybridization, what is the structure? The structure is your pyramidal structure. Okay. Now important point is what is about the reactivity of carbanion ion. The reactivity is the tertiary carbanion is more reactive than secondary than primary, which is the reverse order of your stability. If you see the stability, that is an important point. Stability is influenced by two. One is the inductive effect, another is your resonance effect. Now if you see first of all the influence of inductive effect, what is the order of stability? See here the first methyl is more stable than that of your the primary, then secondary, then tertiary. Why that happens? Why the order is like this? Primary is more stable than secondary, then tertiary in a carbanion ion case. Behind it, we know that the alkyl group, that is your positive inductive effect, which shows plus I effect, that increases the electron density on carbanion ion, due to which it decreases the stability of the carbanion ion. So greater here one alkyl group, here in secondary two alkyl groups, in tertiary three alkyl groups. So greater is the number of increase in the number of alkyl group, decreases the stability of the carbanion ion. That is the reason here explained. Okay. Now next point is what is the influence of resonance? Because of the resonance, allyl carbanion ion is stabilized by pi conjugation with double bond, due to which the allyl carbanion ion forms two structures, and benzyl carbanion ion is been more stabilized due to aromatic resonance, and due to its delocalization it forms more than one ring also. Greater is the aromatic ring resonating structures, more is the stability of the carbanion ions.